Okay, so good afternoon. Okay, we are going to continue the chapter 9 PDE. Okay, today is a hyperbolic type equation, wave equations. So the wave equation you can see is the difference with heat equation is the time derivative is up to second order. Right hand side exactly same with heat equation, which is c squared del 2u del x2. So okay, the difference is here. If heat, this is del u del t. So if wave, this is del 2u del t, okay, del t2. And the x is position from 0 to L. Okay, t is okay, greater than 0. Okay, the wave equation is actually describe the displacement of a string which is fixed x at both ends, so that the boundary condition is actually u, okay, because the function same with the heat equation is a u is a function of x and t, so that's why u 0t, because x is position from 0 to L. So the bound, okay, because the u xt here actually describe the displacement of a string. So the string is fixed at the both end. That's why u0t equal to 0, ult equal to 0. And the string is actually, you have the initial displacement, mean the initial shape of the string. Okay, let's say initial shapes. Okay, let's say you have got the initial shapes, maybe. Okay, you have x here equal to 0 until x equal to L. And then let's say the initial shapes of the string you have here. Okay, initial is actually when t 0, so ux 0 equal to fx. So okay, you have actually uxt represent the displacement, okay, of a string which is fixed at, okay, actually both end. So that's why u, okay, when x equal to 0 and u when x equal to L is 0. Okay, let's say initial, okay, displacement of the shape of the string, okay, at initial, okay, shapes there. So it's actually given by a function of x. And then, okay, since the wave equation, the time derivative up to the second, okay, order, second derivative, we need two initial condition. Okay, the second initial condition is actually del u del t. Since u is displacement, okay, the rate of change of displacement, you will get this is velocity. And then when t equal to 0, this is the initial velocity. This is ux0. This is initial displacement. Initial velocity of the string here, of the string, okay, let's equal to gx. Okay, this is the second initial condition. Okay, the string, okay, here you may release it, okay, mean the string, okay, you may pull a bit, okay, and you may release it with 0 in 0, okay, initial velocity, then gx equal to 0, or you may release with certain, okay, initial velocity, then the string will be vibrate, okay. So and then the u here is a displacement, means, okay, how much, okay, the string, okay, move there. Okay, so the wave equation is actually mean, let's say you got the string and then you may pull a bit, okay, and then you release it either with a 0 initial velocity or, okay, certain, okay, initial velocity, and then the string, since is fixed at both ends, it will be vibrate. Okay, mean the vibrations here, okay, when you pull a bit and then you release it, the vibration, okay, of, okay, the string or the displacement, okay, is actually described by this wave equation given by del 2u del t2 equal to c squared del 2u del x2. Okay, and then we proceed to the next one. So the wave equations, okay, same with the heat equation, okay, where we solve it using explicit scheme. Okay, explicit scheme, then we solve, okay, the wave equation here at the xitj. Okay, so u xitj can be simplified as u subscript I comma j. So at this point, the center point, we are standing at the point okay, xitj, and then the u at this point is uij. Okay, and x, okay, we represent using horizontal axis. So okay, from uij, the point ahead will be ui plus 1 j, point at the back will be ui minus 1 j, ui minus 1 j. Okay, and then okay, the time variable we can represent using vertical axis. So okay, from the uij, so the top point is ui j plus 1, bottom is ui j minus 1. Because okay, I, and then right is I plus 1, left is I minus 1. Okay, j describe the time variable. Okay, bottom, okay, j minus 1, center level is j. Okay, top level is j plus 1. Okay, and k is actually delta t. K is delta t. H is actually delta x. Then for the okay, del 2u, del t2, this is second derivative. This differentiate respect to t. Differentiate respect to t. Okay, as you know, okay, if you learn, I think uh, in the ODE chapter, to solve the BBP problem, you have the second derivative, y double prime, you get what? Y I, okay, minus 1. Sorry. Then minus 2 yi plus yi plus 1. Okay, this is your where the y is actually, you have y is function of one variable, which is okay, your y here, y is function of x. X is discretized using I. Now you have function of two variable. I, okay, I is actually okay, discretized for x variable, j discretized for t variable. Okay, when you differentiate respect to t, where the for partial derivative, when you differentiate respect to t, x is fixed. Mean x is fixed at here, this point, xi. And then differentiate respect to t using similar analogy here. So for the del 2u, del t2, you will have here this point similar to yi plus 1, which is uij plus 1, minus 2 times the center point, minus 2 uij, okay, plus uij minus 1. Sorry, y double prime, okay, you divide by h squared, where the h is actually delta x. Okay, for time, okay, they are okay, we differentiate respect to time, the increment is okay, delta t is equal to k. That's why for time derivative, okay, if using okay, CTCS here is actually central time, 2-point central, 2-point okay, okay, 2-point central for time derivative. CS is actually 3-point central. Sorry, CTCS here is actually using 3-point central for time derivative, and then using 3-point central for space k derivative. Then we obtain the finite okay, approximation for del 2u, del t2. Okay, if you look at the molecule, will be uij plus 1 minus 2uij plus uij minus 1 divided by k squared. So you notice when you differentiate respect to t, I, okay, variable which discretize the x is actually fixed. We just vary it, okay, variable j. Okay, so mean you have a j plus 1, j minus 1. The center point is minus 2 times. And then okay, equal c squared. For del 2u, del x2, we differentiate respect to x, okay? And then for partial derivative, when you differentiate respect to x, time t is actually fixed. Okay, because we discretize at the point xitj. That's why okay, t is actually fixed at level j, and then you differentiate respect to x. So using similar formula with the y double prime in the ODE chapter, you will have here this point ui minus 1j, because when you differentiate respect to x, time t is fixed. So ui minus 1j minus 2uij plus ui plus 1j divided by h squared. So that's why you obtain here. So up to now, okay, do you have any questions about this finite difference approximation? Any question or not?
No, doctor.
Okay, thank you for the response. Okay, if no, okay, so you can compare with the heat equation if using explicit scheme heat equation. Because heat you have is actually left hand side is del u del t standing at the point xitj. Okay, and then del u del t using 2. Okay, for heat equation is actually they said the scheme forward time center space. So heat equation left hand side is actually they use 2 point forward. That's why you have is actually uij plus 1 means standing at the point xitj. That's why you take uij plus 1 minus uij. Okay, uij plus 1 minus uij divided by k. This is the left side for the heat equation. Right hand side for heat and wave are same because they have the same term, which is c squared del 2u del x2. Okay, after that, okay, so you observe the heat the explicit scheme for heat equation is actually you have two level, okay, two level scheme only, two level mean level j and j plus 1. Okay, and then for implicit heat equation, okay, using Kronecker-Nicholson implicit scheme for heat equation, okay, the center level is actually j plus half, j plus half. Then you still have a from j plus half to sorry j, okay, from j plus half to j plus 1, still two level. Okay, and then now, okay, so we have this three level. Okay, when you see when you want to find the del 2u del t2, we have a three level. So later on we express uij plus 1. Mean from here you need to express out uij plus 1. Hence k squared you bring to right hand side. Okay, the terms, okay, mean the term is not from level j plus 1, you bring to right hand side. Okay, that's what you obtain like here. And from here in the previous slide, k squared you bring to right hand side. That's why you have k squared c squared over h squared, where we denote it as rho squared. Rho squared. So okay, that's why the right hand side it become rho squared. Okay, bracket you still have the term ui minus 1j minus 2 uij plus ui plus 1j. Okay, and the left side, okay, you want to put back this is plus 1, this is minus 1. Okay, doesn't matter. Then after that, collecting the term uij plus 1, okay, as a title. So uij minus 1, you bring to right hand side, become minus uij minus 1. Okay, that's why you see, okay, uij minus 1, the coefficient is negative, okay, negative 1. Uij plus 1, the coefficient is 1 time. And then equal, that's why 1 time of uij plus 1, okay, is equal to, okay, and here you expand in, so you have a rho squared ui minus 1j. That's why the left middle level, okay, the coefficient is rho squared ui minus 1j. Okay, and then this one, okay, when you expand, you have minus 2 rho squared. Okay, you collecting the u, okay, minus 2 uij together, so become positive 2 minus 2 rho squared uij. Okay, and the ui plus 1j, okay, expand with multiply with rho squared, so it's plus rho squared ui plus 1j. So from this equation will be easy to, okay, if we can represent it using molecule form. Then you can see, okay, 1 time of uij plus 1 is actually equal to rho squared ui minus 1j plus 2 minus 2 times rho squared of uij plus rho squared of ui plus 1j minus 1 uij minus 1. Okay, and then why here we said targeted cell at level greater and equal to 2. Okay, we have the initial condition, okay, is what we denote as level 0 because this is j equal to 0. And then we have the level 1. Mean if we use this 3 level scheme, 3 level scheme, we have the initial condition, mean we have the level j level 0, and then we need, okay, what is a level 1 here? Mean you need this, okay, level 0, level 1, then you can calculate level 2. Okay, later on, okay, you have the 1, 2, then okay, level 1 and 2, you can calculate level 3 and so on. Okay, then how to calculate level 1 here? Okay, you have to calculate level 1 before you can apply this 3-level molecule. So to calculate level 1, remember, okay, the wave equation, we have 2 initial conditions. Okay, so now we apply the second initial condition, because the first initial condition you apply, okay, to the level 0. Then we can apply the second initial condition, which is del u, okay, del t when t equal to 0. Okay, okay, and then you see differentiate respect to t. Let's say you're standing here u I j. Okay, at the bottom is u I j minus 1. Top is u I j plus 1. Okay, and then when t equal to 0, j equal to 0. Okay, that's why you have here, this is u I 1, this is u I 0, then you have u I negative 1. Then, okay, del u del t. Del u del t, okay, when t equal to 0, this is first, okay, derivative. First derivative. Then we use, okay, this one using 3-point central formula for first derivative. Okay, for 3-point central formula, we are standing at here ui 0 because t equal to 0. Then you take the point ahead, which is ui 1 minus ui minus 1. Okay, and then from ui 1 to ui 0, this is k. From ui 0 to ui minus 1, this is okay, delta t equal to k. So total, okay, their difference is actually 2k. Okay, and then solving for ui minus 1, you obtain ui minus 1 is actually, okay, 2k you bring up, is ui 1 minus 2k gxi. Mean we are going to, okay, in order to get level 1, we have to eliminate this one, ui j minus 1. So when j 0, this is ui negative 1. Okay, up to now, okay, do you have any question or any step that not clear? So remember, okay, please take note, this one, this 3-level molecule is just can be used, okay, for level 2 onwards. Before you can apply this one, you have to, okay, find level 1. To find level 1, you need to use second initial condition. Okay, and then from second initial condition, okay, exactly when you substitute z0, then you can have here ui minus 1 equal to ui 1 minus 2k gxi. So you plug in this thing to here, this one, when you plug here, then you can eliminate this term. You will reduce, okay, from 3-level scheme to 2-level scheme. Okay, like here, that's what we stopped just now. uij plus 1 is equal to rho squared ui minus 1j plus 2 minus 2 rho squared uij plus rho squared ui plus 1j minus uij minus 1. Okay, this is the equation, okay, before we draw the 3-level molecule here. So now we are going to plug in ui minus 1, this thing to here, provided j here you substitute by 0. Okay, and then from this equation, when we let j equal to 0, because t equal to 0, j equal to 0, you obtain ui 1 equal to rho squared ui minus 1, 0, plus 2 minus 2 rho squared ui 0. Okay, and then okay, and then rho squared ui plus 1, 0, minus, okay, ui when j is 0, ui negative 1 is ui 1 minus 2k gxi. Gxi is actually the initial velocity. Okay, after that, okay, when you're collecting ui1 to left hand side, okay, when you're collecting ui1, okay, to here, total you got 2 times ui1. Okay, this one minus ui1, you collect to left side, total is 2 times. So negative negative, this term become positive. Okay, what you want is actually 1 time of ui1. That's why you divide, okay, both hand side by 2. That's why you obtain rho squared over 2 ui minus 1 0 plus, okay, this one divide by 2. So 1 minus rho squared ui 0 plus rho squared over 2 ui plus 1 0. Okay, this one because you already collect 2 times. So negative negative, this become, and then divide by 2. So become plus kgxi. Then from here, you can draw, okay, to the molecule. We obtain 1 time of ui1. So here 1. So mean only okay, so this 2 level, okay, molecule is only specific for level 1 only. So this is ui1. 1 time of ui1 is actually equal to rho squared over 2 ui minus 1 0 plus 1 minus rho squared ui 0 plus rho squared over 2 ui plus 1 0 plus kgxi. Okay, where the gxi is actually from your del u del t, okay, x when t 0 equal to gx. So you observe, okay, if let's say if gx equal to 0. Okay, if gx equal to 0, you don't have this term. Okay, and you observe, okay, this 3, okay, level molecule and the 2 level is actually, okay, especially when gx equal to 0, this term, okay, mean when gx equal to 0, you can notice that, okay, this term 0. That's why ui minus 1 equal to ui1. That's why this term, okay, negative 1 bring to left side become 2 times. 2 times. So that's why all the coefficient here you have to divide by 2. That's why obtain rho squared over 2. This will become 1 minus rho squared. This become rho squared over 2. Okay, this is what you have here. Okay, this one, if gx is 0, then you don't have, okay, this term. If gx not 0, then you have to add up with plus kgx. Okay, before, okay, we proceed to the example, do you have any questions?
No, doctor.
Okay, thank you very much. Okay. Okay, if no, we proceed to, okay, example 1. Okay, given the wave equation del u del t equal to 9 del 2u del x2. So, okay, from the coefficient of 9, this represent c squared. Solving x from 0 to 2. Okay, t is positive with the boundary condition. Okay, sometime, okay, the question they didn't give you a boundary condition. They must understand the wave equation because it's fixed at both ends. That's why left boundary and right boundary are always 0. Okay, and the t is actually solved from 0 up to 0 0.04. Okay, and the initial condition ux0 equal to sin pi x del u del t, okay, when t equal to 0 is sin 2 pi x. Okay, x from 0 to 2. Okay, using finite difference method, and this is an explicit, okay, finite difference method, solve the wave equation by taking h equal to delta x equal to 0.5 and k equal to delta t equal to 0.02. Okay, and then we can calculate, okay, the rows you have here. C squared is 9. So you calculate the rho squared is actually k squared c squared over h squared. K given is 0.02 squared, and then c squared is 9, h squared is 0.5. Okay, you obtain 0.0144. Hold on. I need to show the calculator. Okay, so you have here 0.02 times 9 divided by 0.5 squared.
0.02
squared.
square.
Squared. Okay. K squared. Here 9 is C squared. 9 don't square it anymore. Okay, you get 0.0144. Okay, and then 2 minus 2 rho squared. 2 minus 2 time. Okay, rho squared is safe in answer. So you get 1.9712. Then you can plug in, okay, into the 3-level molecule to calculate level 2. So you have 1 time of uij plus 1 equal to, okay, and then here, you may edit using 4 decimal place, 9712. Okay, so this is the 3-level molecule. You have 1 rho squared is 0.0144. 2 minus 2 rho squared is 1.9712. Okay, and then rho squared 0.0144. Okay, the bottom's one is minus 1. Okay, the left, middle, cell we represent using A, center middle B, right middle C. The center bottom we represent using D variable. Okay, and then before you can calculate level 2, you need, the molecule for level 1. Okay, molecule for level 1, okay, is actually, you have here 1. Okay, this is actually, half. From the middle level here, the coefficient, you divide by half. So 1.9712 divide by 2, 9856. Okay, you change this one to 9856 using 4 decimal place. Okay, and then 0144.0144 you divide by 2. Okay, 0072. This is 0072. Okay, and here gx is given sin 2 pi x. Then you need to add up plus k gx plus sin 2 pi x. Okay, up to here, and any question or not? Mean just plug, calculate the rho squared. 2 minus 2, 2 rho squared put into the 3-level scheme. So this scheme can use to calculate level 2 onward, and then you need to calculate level 1 first before you can calculate level 2. Okay, level 1, from the middle level, all the coefficient you divide by 2, then add up with k gx. Gx is from del u del t when t equal to 0 here. And then, to calculate level 1, this is a left bottom cell. We can represent using variable A. Center, center bottom we use B. Right bottom we use variable C. Okay, after that we can draw the grids. Okay, you can draw the grids here. T from 0, increment 0.02 up to 0.04. Okay, and then the X from 0, 0.5, increment is 0.5, 1, 1.52. Okay, left boundary and right boundary are 0 for wave equation because the string are fixed at both ends. Okay, initial condition is actually given ux0 equal to sin pi x. Okay, you may directly 3 point only. You may either you use a table mode to calculate, or you may calculate one by one. Sin, calculate, when x0, you see whether they overlap. X is 0.5. Okay, x is 0.5. You get 1. Okay, calculate. Okay, when x is 1, you have 0. You calculate when x is 1.5, you get negative 1. Okay, calculate when x is 2, 0. Okay, this is using normal calculate menu, or you can just use table menu, to tabulate it quickly. Okay, sin gx. Okay, starting from 0, ending is 2, step is 0.5. So you have 0, 1, 0, -1, 0. So you got 0, 1, 0, -1. The last one is 0. So you see initial condition and the boundary condition at the intersection point must be same, same value there. Okay, so now we want to calculate, okay, this is a level 0, level 1, sorry. This is level 1. Okay, level 0 from initial condition, and then level 2. So to calculate level 1, okay, you must use that 2-level molecule. This one, yeah. So you can put it into your calculator. Mean you target at, okay, one of the cell at level 1. Okay, especially let's say you target at U11, then it's equal to 0.0072 time of the left bottom cell plus 0.9856 time of center bottom cell from what, okay, from where you target, and add up with 0.0072 right bottom cell from the cell that you target. Okay, then you may input, go to the calculate menu, put out 0.0072. Okay, left bottom cell, let represent using A, and then center bottom cell, let 9856, let represent using variable B. Okay, and then the right bottom cell, the coefficient is 0.0072 C. Okay, and then you calculate, then you move to the grids. Okay, means now we target at here. We want to calculate this value. Okay, this value, okay, when you see you use a 2-level molecule, you will target like this. This is equal this. So this is A, B, C. Okay. Then A is 0. Okay. B is 1. C is 0. So you obtain 0.9856. Okay, up to now, okay, this is explicit scheme, mean, okay, explicit scheme, the top level is normally one cell only. If you see Crank-Nicholson implicit scheme, top, okay, even though 2-level, top level, okay, the targeted top level, you have more than one cell, so it become, okay, implicit, because you cannot, okay, directly obtain, okay, the value, but you have to solve this linear system. Okay, so up to here, is it any questions?
Doctor, why the calculation only plus to 0.02 sine 2 pi x?
Yeah, you are right. But coincidentally, the sine 2 pi x 0. Okay, you are right. Okay, suppose we need, okay, to add up. Yeah, okay, I forgot this term. But okay, okay, luckily this term at the x 0.5 is equal to 0. Okay, actually we need to add up this one. Okay, we need to add up, you're right. Because gx is not 0. Okay, but luckily because, okay, when x is 0.5, mean you have half, x is 0.5. Mean just suppose I need to add this term, 2 pi, okay, 0.5 x is half, 2 sin pi equal to 0. That's why just now I didn't add up, I still get the result. But correct step is actually I need to show to you. We need to add up this step, C, and then here plus 0.02 sin 2 shift 2 pi shift pi here alpha x. Okay, so now I add up this one plus k, gx is sin 2 pi x. Okay, then where is it? move to here. Okay, we see again. Okay, we calculate again. A is 0, B is 1, C is 0. Okay, okay, X. Okay, X is from where you target. You target at here. You want to calculate 0.9856, you target at here. So X is here, 0.5. Okay, then you input X 0.5. 0.9856. Okay, because coincidentally, the term sin 2 pi x when x is 0.5, the result is 0. Because you have the term is plus 0.02 sin 2 pi. Okay, when x 2 pi, when x is half. Okay, x is half, you got 2. Sin pi is 0. Because you got sin pi equal to 0. Okay, when x is 1 also, when x is 1, sin 2 pi also 0. Okay, x is 1.5. Okay, you get, let's see, when x is 1.5, sin 2, 1.5 is 3 over 2. Okay, you get sin 3 pi, also 0. So that's why just now I forgot to add up this term, still get the same result because luckily sin 2 pi x for the x 0.5 1.5 leads to 0. Okay, after that, to calculate the next value, this one u21, this is u11, this is u21. Then you move your molecule, target the molecule at this cell. Okay, so now we erase here. Okay, mean to calculate the value, this value that we target here. So you move the molecule like this. So this is A, this is B, this is C, this is X. Okay, so you calculate again. Now A is 1, B is 0, C is -1, X is 1. So you get 0. Okay, is it okay? And then, the explicit scheme should be easier than the implicit. Next, to calculate U31, this one. So A is the left, B is the center, bottom, C is the right, bottom. This is C, this is a X. Okay, and then you calculate. So A now 0, B is -1, C is 0. C 0, X is 1.5. So you get -0.9856. So we completed level 1. And after you completed level 1, don't too excited to use, because some of you, you finish level 1 and then you may, to calculate this one, then you use, if you use back 2 level scheme, you still can get the value, but it's wrong. Mean, you understand? So for level 2, if you use the 2 level scheme, then you take this is A, this is B, this is C, Then you need the x, you take the x is 0.5, you can get the value, but it's wrong value because it's a wrong wrong molecule. I mean, if you use like this, if you continue using that two level scheme to calculate a level 2, you of course you can get the value, but it's wrong. Let's say you use A0 B 0.9856 C0, and then x 0.5. You see now you get 0.9714, but the correct answer is 0.9428. So be careful, for wave equation. These two level scheme to calculate level 1 only. That's why you put UI. Suppose this one you can specify UI1. UI1 because when the bottom level is actually initial condition J is 0, then you can calculate for UI1 only. And then to calculate level 2, you need these three level scheme, and you see their coefficient compared to two level. The scheme here center middle level here, the coefficient is twice. Then we key in the molecule for three level scheme. This one I can delete. I got minus D. Here minus D, and the coefficient is actually double 0 0.0, 0.001 0144 0144. 1.9712. So now we key in the molecule for level 2 onward. So one cell of the targeted level is equal to 0.0144. A represent the left middle cell, plus 1.9712. B represent the center middle cell, plus 0.0144. C represent the right middle cell, and then minus D actually represent the center bottom cell, minus D. And then move to here to calculate this value 0.9428, or this is U12. Mean X is 1, J is 1, I is 1, J is 2. So this is U12. Then now you can you see A, B, C, D is actually here. So this is A, this is B, this is C, this is D. Calculate. So A0, if value correct, you just press down. B 0.9856, C0, D is 1. So you get 0.9428. Is it okay? The first value U12.
Okay, doctor.
Yeah, thank you. And then to calculate the next value in level 2, move your molecule, move the molecule one column to the right. So mean you target here. The whole thing you can shift it one column to the right. Then this one no more, this value can delete. This one no more, this one no more. This will become A, this become B, C, D here. So you target this one, this is your target. So A here, this is B, this is C, C at here. Now D bottom. Here no more. So A, B, C, D. So calculate again. Now A is 0.9856. B 0. C negative 0.9856. D 0. So you obtain 0. So to calculate the last value in your level 2, okay, move the molecule one column to the right hand side. Okay, then this one no more. This one no more. Okay, here no more. Okay, now to calculate this value, so here this is A, this is B. Okay, C at the right boundary, D is negative 1. This is D. Okay, then you calculate again. A 0, B negative 0.9856, C 0, D negative 1. So you get negative 0.9428. Okay, this is calculate manually using your scientific calculator. So be careful, okay? This, okay, jot down this one. This 3-level scheme is used to calculate level 2 onward. Mean if level 3, 4, 5, use this 3-level scheme. This 2-level scheme is only for level 1 only. Okay, and then do you have any question before we proceed? Let's say to see, okay, to solve using your Microsoft Excel. Okay, if no, we'll keep using this one. Okay, this one I erase. Okay, so the example 1, you have a del u del t equal to 9, del 2u del x2. So c squared is 9. Okay, k is 0.02, h is 0.5. Then you calculate the rho squared, which is a k squared c squared over. Okay, rho squared is actually k here, k squared multiply c squared. So be careful. 9 is already c squared. Don't square it anymore. So divide h. Okay, c9. C9 squared. So you get 0.0144. And then you calculate 2 minus 2 times rho. Okay, this is already rho squared. So you get 1.9712. Okay, and then the molecule for level greater than equal to 2, 1 time of the targeted cell is equal to 0.01, rho squared is 0.0144. Okay, the center middle coefficient is actually 1.9712, which is 2 minus 2 rho squared. Okay, the right middle molecule coefficient is 0.0144. Center bottom molecule coefficient is negative 1. And then to use this 3-level scheme, you need the level 1 information before you can calculate level 2. Okay, and level 1 is actually is only half of your coefficient in the middle level from 3-level scheme. So this one you just divide by half. Okay, half. And then if the del u del t when t equal to 0, okay, is not equal to 0, then you have to add up k sin 2 pi x. Okay, because here gx is sin 2 pi x. Okay, or I may add up to here. Okay, and I put out t is solving up to 0.04, with increment 0.02, then we have 0. Okay, x from 0, okay, increment is 0.5. Okay, and then solve up to 2. Here, 2. So this is a x. Okay, initial condition is actually here. This one, t is discretized using j. J is actually, okay, put up j here. J, t discretized using variable j, j 0, 1, 2. So this is what we call level. So level, okay, refer to the j, okay, variable. So level 2, level 1, level 0. Okay, level 0 is actually from initial condition when t equal to 0. So ux0 given is sin pi x. Okay, so you may type it sin pi is pi open close. Okay, to type, okay, to use pi in Excel, pi open close bracket, then multiply with x, okay, x bottom close, okay, sin, okay, open close bracket. Okay, so you get 0. You can copy it. Okay, you see, okay, this is actually 1.2 times 10 to the power of negative, okay, 16 is, okay, is actually equal to 0, or you may format the cell here, change number, let's say take 2 decimal place. So it's 0 actually. Okay, take the number, so it's 0. Okay, and for wave equation, left boundary and right boundary are always 0 because the string is fixed at both ends. So you see overlap with the initial condition. Okay, after that, you want to calculate, okay, this cell is actually U11. Okay, you want to calculate U11, and I label to it U21 is here. This is actually U31. This cell is U12. Okay, this is U22, U32. Okay, okay, I want to calculate here. So to calculate U11, you will target like this. Okay, let me put it here. So using K to level 1, you need to use K, that level 1 molecule is actually 2 level. Okay, and then here level 1, because del U del T not equal to 0, you add up with K times sin 2 pi x. Okay, so I'm not calculate yet. Okay, I go to create for you to see this is x, gx here, gx sin 2 pi x. Okay, calculate sin 2 pi x below the xk variable. So this is sin 2 times pi time x is on top, which is C23. Yeah, C23. So you can see, okay, I change the format to numbers. So you can see that the gx, okay, when gx is sin 2 pi x, the value, okay, for gx is actually 0 for all the x, 0 0.51, 1.52. Okay, and then to obtain U11, so you use the molecule for level 1 here. Okay, you take the molecule from level 1, multiply, okay, mean you target at here. So it's 0.0072 times left bottom cell. Either you type in the value, or if you click the location of 0.0072, make sure you constant it. Okay, by putting dollar front and dollar back. Okay, this is a left bottom coefficient, so you need to multiply with left bottom cell. Okay, plus Okay, center bottom coefficient. If you click location, make sure you constant it. Otherwise, you please key in 0.9856. So multiply center bottom molecule plus, okay, the right bottom coefficient. So if you click location, please constant it by putting dollar front and back. Then multiply the center bottom cell. Okay, if you want to add up with K, which is 0.02, 0.02, sin 2 pi x, I already calculate here. This one, if we use Excel, you see, okay. So this is a center bottom coefficient multiply center bottom cell plus center, okay, sorry, left bottom coefficient multiply center bottom cell, okay, sorry, left bottom coefficient multiply left bottom cell plus center bottom coefficient multiply center bottom cell plus, okay, right bottom coefficient multiply right bottom cell plus K, which is 0.02, multiply sin 2 pi x, okay, the value here, the value where I already calculated below the x-axis. Okay, then I get 0.9856. Okay, and then I just copy it, okay, to the right hand side. Okay, this cell you may format it, change to number, so you get here. So you can see it's tally with what you obtain using, okay, manual, but it's much faster. 98560 negative 0.9856. Okay, after you obtains the level 1, then you apply 3 level molecule to, okay, to get your to calculate U12. It's like this. U12. Yeah. So to get U12, applies a 3 level molecule. So is, okay, click the, okay, the coefficient for 3 level molecule. Make sure you constant it. Then multiply. Okay, you see you key in at D20, so your go down one level, this is a left, multiply the left, okay, the left middle, okay, cell plus this one, the coefficient for center middle level coefficient, multiply here center middle cell plus here the coefficient for right middle coefficient, multiply right middle cell minus, okay, because it's minus 1, so I should minus, okay, from what you target just now, D20 go down 1 2, so it's here. And then just copy. So 9428, compare here, 9428. Okay, so this is using Microsoft Excel. Okay, and this one you may change it, let's say to number. Okay, if you want to round, you can round to 4 decimal place. So mean in level 1, okay, orange color using this, okay, level 1 molecule. Okay, level 2 onward using the 3 level scheme. Okay, let's say you want 0.06, then you can select the whole level 2, copy it up. So this is, okay, using Microsoft Excel. So do you have any questions here? Okay, if no, okay, the example 2, similarly, we can okay, del u del t equal to 4 del 2u del x2. K is 0 0.1, h is 0 0.25. Okay, this one even easier because del u del t equal to 0 means gx is equal to 0. Okay, and then let me delete everything first. So c squared is a coefficient for del 2u del x2 is 4. K is 0 0.1, h is 0 0.25. Then you calculate the rho squared is k power 2 multiply c squared is 4 divide your h, okay, c9 c9 power 2. So you get rho squared is 0 0.64 and then 2 minus 2 time, okay, rho squared you have 0 0.72. So the molecule for level, okay, greater than equal to 2, okay, 1 time of the targeted cell equal to rho squared, which is 0 0.64, okay, plus this is, okay, multiply the left, okay, middle level cell plus 0 0.72, which is 2 minus 2 rho squared, multiply the, okay, center middle cell plus 0 0.64 right middle cell minus 1 time of the center bottom cell. And for level 1, okay, level 1, because gx 0, then you can easily obtain the level 1 by, okay, take the middle level of a level 2 divide by 2. Okay, after that, okay, we can build in t, okay, t up to solve example 2, okay, up to 0 0.2, 0.2 here, 0.2, increment is 0.1, okay, 0, and then the x, okay, 0 up to 1, increment is 0.25, okay, and then the initial condition is when t0 u is x times 1 minus x. So you have x times 1 minus x. So you see, okay, left end, right end, which is left boundary, right boundary for the wave equation, okay, are always 0. And the left boundary, right boundary for wave equation are always 0 because the string is fixed at both ends. Okay, so now you need to find, okay, like just now, u11, u21, u31, then here u12, u22, u32. Okay, then I can copy it again. Same with just now, equal to, for level 1, and this is level, okay, level 0 from initial condition, level 1 from 2, okay, level molecule, level 2 from 3 level molecule. So level 1 is take the, okay, the left bottom coefficient and then make sure you constant it, otherwise you type 0 0.32, this one multiply, okay, the left bottom cell, okay, from where you target, you see, okay, go left is go down, and then, okay, go down, okay, is bottom, and then go to left. Okay, so plus this coefficient 0 0.36. If you click the location, please constant it by putting dollar front and back time. Okay, from where you target, key in the formula, exactly go down, same column, plus here multiply, okay, the right bottom cell. So you get 0.1475. Then you make, okay, copy it to right hand side. Okay, this one. Let's say we use in first round. Just now we use like this 0.1475. You can check 0.1475, 0.21, 0.1475. Yeah. So after that, to calculate U12, okay, what I mean is, okay, don't use these two level scheme to copy it up. If you use it here, copy it up, you can get the value, but the value are wrong. Because okay, this scheme is for two level scheme for level 1 only. So don't too excited to continue copy it up. So this is wrong. So for U12, okay, make sure you apply like this. Okay. U12, make sure you apply this three level scheme in order to get your U12. Okay, so you have here equal. So you at the cell U12 type equal, take the coefficient of your left middle cell coefficient, and make sure you make it constant. Okay, then from where you key in the formula, go down is a middle level left plus this coefficient, make constant, multiply from where you key in exactly down one level, same column, plus the coefficient 0.64, constant it, multiply from where you target is D22, the right is a E, and then go down is a 23, so D23. So minus one time, so minus from where you target D22, 1, 2, same column, so D24. Okay, so 0.0531, 0.0531, 0.0531, 0.009. So you obtain this one. So this is using two level scheme. This is using three level scheme. So this is using Microsoft Excel. If you want to use manually, then you have to key in to your calculator for the two level molecule for to calculate your level 1. Then you have 0.32 alpha A plus 0.36 alpha B plus 0.32 alpha C. You don't have this part because gx is 0. And then how you get U11, and how you get this one U11. To get U11, A is 0, A 0, B is 0.1875, C is 0.25. Calculate A 0, B 0.1875, C 0.25. So you get 0.1475. Later on, to calculate U21, U21 here, and later on, let's say I just change color. Let's say to calculate the blue, then A here, A, B, C. Because the pattern is repeated, that's why you just key in the U11 formula. You can copy down the formula in Excel. So you calculate again. A is 0.1 0.1875. Okay, A, B is 0.25, C is 0.1875. So 0.21. Okay, and then let's say use green. Okay, let's say to calculate U31. So you see A now here. A move to here. This is A, B, C. Looking at the green color. So calculate. You target here. A left is 0.25. B here 0.1875. C 0. So you get 0.1475. Okay, this is level 1. Use 2 level scheme. Okay, and then to calculate level 2 onward, okay, you need this 3 level scheme. Where we can here minus D. Okay, from 2 level scheme to 3 level scheme, okay, their coefficient actually times 2. So this is 6, 4, 72. Then 6, 4. Okay, and then erase it. Okay, now to calculate, this is a U12. Okay, you have your A. A is here. This is B. This is C. This is D. Okay, so you calculate A is 0. B is 0.1475. C is 0.21. Okay, D is 0.1875. So you get 0.0531. Okay, and then to calculate U22, okay, I have to erase, otherwise very messy. And to calculate, this is U21. Okay, I just put this is A, this is B, this is C, this is D. So calculate again. A now become 0.1475, B is 0.21, C is 0.1475, okay, D is 0.25. So you get 0.09. Okay, and then the last one, to calculate the last value in the level 2. Yeah. Where's that? What happened? Okay, I want to pen ABC. Okay, now I want to erase it. Why? Yeah, why cannot erase? You cannot erase. I change color. Okay, now to calculate, use the blue color. So A is here, B, C, D. Blue. A, B, C, D. So calculate again. A is 0.21. B is 0.1475. C is 0. D is 0.1875. So you get 0.0531. So this is manually using the normal calculate menu. Okay, here 1, 2, 3, 4, 5 column. Okay, 5 column. If you want to use the spreadsheet menu to perform it, okay, still okay. Let's see. No. So it's easy. Bottom 1, 2, 3, 4, 5. Okay, you can key in the left boundary. Go up. A, B, C, D, E. Cell go up 0, 0, 0. Okay, try to put up exactly same in the micro spreadsheet menu in the classic model. Okay, mean in the your spreadsheet menu in the classic model, this is column A, B, C, D, E. Then this is row 3, 2, 1. Okay, and this is a initial condition x times 1 minus x. Okay, so here, oh, so you need one more x. Okay, x 0, 0.25. Okay, we enter it, go down, and then you need to move up 0.5. Okay, 0.75. Okay, this is 1. So the fourth row represent the x value 0, 0.25, 0.5, 0.75, and 1. Okay, now I need to calculate the initial condition. I want to calculate 0.1875 using the initial condition x times 1 minus x. So alpha calc to get equal. Okay, x is stored 0.25 is stored in B4. So you just put alpha B4 bracket 1 minus x. X is B4. Close it. So mean when you calculate this one, 0.1875 x times 1 minus x. X is actually 0.25. 0.25 is stored in B4. Okay, then you equal. So you get 0.1875. And then if you use spreadsheet, you can copy. To copy in the the spreadsheet menu, in classic model, you press the options, go down, copy and paste to. Okay, click right to, and then equal to paste it. So you get 0.25. Okay, right to paste it. You get 0.1875. Okay, you paste this one, you see you still get 0. Okay. So we calculate row 3, which is initial condition. Okay, now we move to the cell B2. B, this is 2. Column row 2, B2, to calculate U11. Okay, to calculate U11, mean using this molecule 0.32. Okay, so mean the B2 here is to calculate the cell B2 in the spreadsheet menu to calculate the cell U11. So using the 2-level molecule, so alpha equal 0.32. Okay, ui minus 1j is actually your left bottom cell. Okay, from where you key in the formula B2, left bottom cell is A3. So put out alpha A3 plus 0.36. Okay, uij is actually the center bottom column B, so B3. Because you are keying at B2 means you target at B2, so your center bottom is a B3. So alpha B3 plus 0.36. Okay, so A3, B3, C3, because they are same, okay, same row is at number 3. So A, B, C. So C3, alpha C3. Okay, equal, you see here. Check the value here. 0.1475. Okay, I get 1575. Okay, 3, 2. C, okay, check the formula. Okay, to see the formula, suppose 1475. Okay, shift, no. Mm, options. No, this one. Okay, edit cell 3. Okay, see the formula 0.32A3 plus 0.36B3 C3 AB3, correct? A3 A3. Oh, formula wrong. 0.32 C3 at 0.332. Wrong formula. Okay, I key in the wrong formula. Here 0.32, left bottom is, okay, A3, center bottom coefficient 0.36, right bottom is 0.32. Okay, so now you get here 0.1475. 0.1475. Okay, go up. Now you can copy the U11 formula. So to copy it is not as easy as Excel. You just drag it, but here you need to press options, go down, press number 2, copy and paste. So copy, okay, move to right side, okay, click equal to paste. So you get 0.21. Okay, point to, okay, D2. Okay, press equal. So you get 0.1475. Okay, done, copy, paste, AC. So you get the level 1 already. Okay, after that, use this 3-level molecule, to calculate your level 2. Okay, so move. Now in B1. Okay, so alpha count to get equal. So it's 0.64, 0.64. Okay, left middle level. You key in B1, your left middle is A2. So alpha A2 plus 0.72. From A2 will become, okay, your center middle is B2. Alpha B2. Then plus 0.64. Okay, alpha C2. Because your middle level at row 2. Okay, left, center, bottom, left, center, and right is the cell A, B, C. Okay, and then minus the center bottom. You key in B1, center bottom is B3. B3. So alpha B3. Okay, you check the answer. 0.0531, correct. Okay, and then go up. Okay, make sure you are in the cell B1. Then to copy the U12 formula, make sure you're in the cell B1. Then options, go down. Number 2, to copy paste. Okay, click move to right hand side, click equal to paste. Okay, get 0.09. Okay, move to D1, click equal to paste. Okay, done, paste, AC. So this is using the spreadsheet menu in the Classwiz calculator. You use the ability to copy paste, but to copy paste, okay, is not that straightforward like Microsoft Excel, where you just click, get the little plus, okay, at the right bottom cell, and then you drag it. Here you need to copy and then, okay, click to the cell they want to paste, okay, paste it one by one, but still faster than Okay, you use okay, the calculate menu where you calculate one by one. So this is okay, all about the wave equation. So okay, we have shown you using calculate menu. Okay, this is using the spreadsheet menu and using the Microsoft Excel. So it's up to you to choose okay, one of the technique that you prefer. So any question that you want to ask or not?